Okay, example 2. Does the intermediate value theorem apply on the specific intervals for the piecewise functions shown below? Be sure to explain completely. Okay, part A. Is there a value x equals c on the interval -2 to 5? So from -2, so there. All right, let's get it again. All right, so from -2 to 5, which is here. All right, where f of c equals 1. All right, let's travel. All right, no, 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 no. And then we jump. And then we're going up, 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 up. Oh, we got one right there. So yeah, we do. All right, so we do have that value, but just because you have the value doesn't mean it was absolutely guaranteed to happen. So yes, there is a value x equals c where f of c equals 1. Okay. On that particular interval. So I'm just trying to be as wordy as I can there so there's no mistaking. All right, so let's make that a little bit bigger and let's move that over right there. All right, yeah, there is. Okay, now, did the intermediate value theorem guarantee that value of c to happen? No. And the reason it wasn't guaranteed, just because it happened, didn't mean it was guaranteed to happen. So no, and the reason, we could yell it, no, the intermediate value theorem does not apply due to f of x not being continuous. There's a break there on that interval. All right, so on the interval we're talking about, which was -2 to 5. Okay. All right, let's make that a little bigger and make that look a little bit better. Okay, there we go. Okay, cool. Okay, so yeah, it happened, but it wasn't guaranteed to happen. All right, it's kind of just because something happens doesn't mean someone promised you it would. Okay, that's kind of the logic thing there. Okay, C. Is there a value x equals c on the interval 1 to 6? So just this part right here, where the y value or the function value is 3. No. All right, so there's no. Uh, we don't see that at all. But the reason now that it's not, the intermediate value theorem did not apply, will be different. Okay, so we'll talk about that in just a moment. All right, so no. Okay, you gotta have the cursor in there, I suppose. There is no value x equals c where f of c, and I hit x every time, c equals 3 equals 3 on the interval 1 to 6. Okay, there was not. All right, so let's make that a little bigger. Okay, now, did the intermediate value theorem hold? No, not because of continuity this time. All right, up here was a lack of continuity. Now it's the fact that 3, f of c equals 3, is not in between f of 1 and f of 6. So I wasn't guaranteed for that to happen, and it did not. I mean, you can, like, it could take off from here and go up and then come down, but it was just a linear segment there of it, and so it didn't. All right, and it wasn't guaranteed to happen anyway. So there we go. So let's see. So no. All right. The intermediate value theorem does not apply this time due to 3 not being in the interval f of 1 to f of 6. That's g this time, isn't it? All right, so fine. I'll change it to g. To g of 6. Okay. And there we are. So we weren't guaranteed to hit 3 at all. I mean, we could hit 3, but we weren't guaranteed to hit 3 because 3 was not in between those two y values. That y value and that y value did not include 3. So we weren't guaranteed for that to happen. All right. And it didn't. So there we go. Okay, so what are the conditions then? Okay, so the conditions for the intermediate value to be applied is, first of all, the function's got to be continuous. So f, and I'll say f of x. So f of x must be continuous on f of, oh, sorry, on a to b. Okay. All right, now, so that was the first one that messed up, all right, on part B, okay? So the second thing was, and what messed up on part D was that it has to be in between. Well, they call that part 3. But part 2 is one we haven't really talked about yet, and is they can't be the same, because if they were the same, you don't have anything between them. So I'm talking about the function value. So f of A is not equal to f of b, because then you got nothing between them. so there's nothing to conclude. All right, so let's make that bigger and let's move that over. Okay, next, the last thing then is that the function value you're trying to find, c, f of c, has to be in between. Okay, so let's see, let's do that. Looks like I'm gonna be writing this time. All right, fine. Okay, so here we go. All right, so the last thing is that f of a, I'd like this to be a little bit bigger. There we go. All right, so there we go. F of a is, I mean, it could go either way. They could have been greater, right? So f of, I'll just put both of them. All right. So f of a is going to be less than f of c, which is less than f of b, or it could be flipped around. All right. Or f of b, f of a is greater than f of c, as long as it's in between the two. It's greater than f of b. As long as that happens, as long as your y value is between, it's continuous, and a and b are not the same thing, then you got it.